All right, so here we go. Module 4, Lesson 18. We just finished with the mid-module assessment. Now we're on to the second half of this module, and it's luckily a little bit shorter. Not much, but just a little shorter than the half that we just did. So today we're going to be talking about writing and evaluating addition and subtraction expressions, but this time in real-world situations. So before, we were just doing them for math situations. Now we're actually looking at them in real-world situations. So let's actually take a look here on page 2 of this lesson. So first thing it asks us to do is to read the variable in the table and improve the descriptions given, making it more specific. So here, we're given this variable of j, and that represents Josh's speed. So we're going to say let j equal Josh's speed. But here's the thing. Josh's speed in what? I need to be more specific. This is incomplete, so this is bad. Well, it's not bad, but it's not complete. But I don't want you to write them like this. So let's actually write a good one. So a complete description would look more like this. I'm going to say let j equal Joshua's speed, and I want to give a unit of some sort. Joshua's speed in, let's say, feet per second. That's a better unit for speed, but not every unit is like that. So here's what I want you to try. Take a look at this next one. It says Rufus's height r. Let r equal Rufus's height, and then see if you can improve the description here. So Rufus's height in what? So right now, pause, take 30 seconds, try to write your own, and come back and see if you got it or if you had something similar that would work. Okay, so this is someone's height. So if I'm talking about somebody's height, I need to think about it like this. Let r equal Rufus's height in, well, you got to think about what height is normally measured in. You don't say somebody is miles tall. You don't say somebody is feet per second tall. It's just one single distance. So I'm gonna be a little European here. I'm gonna say height in meters. Height in meters. But you could have also said feet. You could have said inches. You could have said centimeters. Maybe even millimeters. But really, one of those is going to work, or meters would work. So any of those I just said would work. Well, now that you've tried one on your own, again, I would encourage you to pause the video, and I want you to try these next three. So we're talking about the amount of milk sold, Colleen's time in running this race, the 400-meter hurdles, and Sean's age, okay? So see if you can complete 1, 2, 3 boxes. Take about 1 or 2 minutes to do that, and then come back and press play when you're done. Okay, so first we're talking about milk sold. So when I think about milk, there's a couple different units you might have. You might have gallons, or you might have cartons, or you might have pints. Let's go ahead and just write down what we have, though. I'm gonna say this. I'm gonna say let m equal the amount of milk sold in, to me, I think milk is most commonly sold in gallons. In gallons. Now, but here's the thing. And another appropriate unit here would have been dollars. So I could have said dollars. I could have said pints. I could have said quarts. You might have even heard of a carton of milk and cartons. Any of these would work. You wouldn't want to do like inches of milk. That wouldn't make sense. You could do fluid ounces. That's another common one. Fluid ounces. If you're not sure if yours works, you could always come ask me. But again, it shouldn't be something like minutes of milk. We don't have time. We don't have time for like. Time doesn't measure milk. We don't say hours of milk. We don't say feet of milk. Those are kind of strange units that we don't use to measure that situation. All right, next one we're talking about Colleen's time in the 400-meter hurdles. The hurdles are the race where you run and you jump over this thing. And you kind of look like that, running and jumping over it. And you race to see who can go the fastest. So when you do this, the 400-meter hurdles is one full lap around the track. So this is a really, really challenging race. I actually ran this in high school, and it was not fun. It was my least favorite race I ever ran. But here, for Colleen's time, we're going to say let C equal Colleen's time. Well, Colleen's time in what? Is it taking her hours, minutes, seconds? Well, we got to think about this. She's running once around the track. The most sensible one would probably be let C equal Colleen's time I would say in minutes, but you could also say seconds for this one. Seconds is another good one for that. But we're talking about time, so it's got to be minutes or seconds or milliseconds or hours or something like that. All right, last one, Sean's age. Now, it depends on Sean's age here. If Sean is a baby, right? If Sean is a baby, not baby, baby. If he's a baby, it's probably months or maybe even minutes if he's a really, really little guy, or even years. In some weird situations, you might say he's seconds old, but pretty much everybody else, everyone else, the rest of us are all pretty much years for our age. So you should have something like this. Let S equal Sean's age in years. That's probably the best way to specify that unit. All right, let's go ahead and move on. So go ahead and find me on page 3. And now we're going to actually work on writing these situations. So we're going to read each story problem, we're going to identify the unknown quantity, and we're going to write an addition or subtraction expression for this, okay? So let's actually see if this works. So Greg has $2 more. I'm going to zoom in a little bit here. Greg has $2 more than his brother Jeff. Write an expression for the amount of money Greg has. So first of all, I need to figure out what expressions I could write here. He has $2 more. So that makes me think plus 2 depending on who I'm talking about. So let's say J. So let J equal the amount of money Jeff has, and we're talking about dollars. So we have to be specific just like we were on the first page. So that means if Greg has $2 more than Jeff, that means I have to take Jeff's and I have to do what with it to get Greg's if he has 2 more. That means I have to add 2 to whatever he has. So this basically means Jeff plus 2, that'll give me Greg. So let's say Jeff has 12. Let's try this. So Jeff plus 2, let's see if this works. Jeff plus 2, okay, what is J? J is 12, so I'm going to say 12 plus 2. That would mean we have 14 here. That's how much Greg has. Greg has 14, so Greg has 14 when Jeff has 12. Greg has 14 when Jeff has 12. So that's kind of weird. It's kind of interesting also. Let's see how this would work the other way. Let's say G was the amount that Greg has. Greg with 2 G's. Greg has in dollars. Now, if this happens, it gets a little different. Let's take a look here. So if we say Greg has 10, we know Jeff has 8. If we know Greg has 7, we know Jeff has 5. So if Greg has 11, Jeff obviously has 9. So if Greg has G amount, right, that's what we're saying. How do we find Jeff's? We take Greg's, right? And how do I get to it? How do I get from 10 to 8? How do I get from 7 to 5? How do I get from 11 to 9? I have to take G and take away 2. So if you think about it, when we switched people, right, we were talking about Jeff, it was J plus 2. When we're talking about Greg, who has $2 more, it's going to change now, and it's going to be G plus 2. So depending on who your variable is, that can change your expression. Now let's evaluate. So when Greg has 14, right, when Greg has 14, I'm going to change that G into a what? Into a 14. And so obviously I can see when Greg has 14, his brother Jeff has 12. So I can say Jeff has 12 when Greg has 14. Jeff has 12 when Greg has 14. Okay, so let's go ahead and see what we can do now. All right, we've got 2 new situations, all right? I want you to see what you can do with these on your own. The only hint I'm going to give you is here. Let's try this. Let's let A equal here, and let's let K equal here. So again, I want you to pause. This one should take you about 2 minutes. Go through, see what you can do, and come back and see how you did on these expressions right here. All right, so when I take a look here, I'm going to say let A equal the number of books Abby has, compared to let K be the number of books Kristen has. So here, it's Abby has read 8 more. Abby has read 8 more than Kristen. So if I have 8, if I have A for Abby, if I want to find Kristen, remember, Abby has 8 more. Kristen doesn't have 8 more. Abby has 8 more. So it means I have to take 8 away from Abby to get Kristen. Oh, and I've got these switched around, but hey, that's okay. So we're going to think about this one up here instead. We'll think about this one. Oh, no, I got this backwards. Write an expression for the number of books Abby has read. So that means we should switch this around. Let K equal the number of books Kristen has. My bad. And let A equal the number of books Abby has. Oh, I'm the worst. So now we don't need to switch them around. So here, if we have K, right, we should have Kristen plus 8. That will give us Abby's. All right? But this one, we know Abby's, right? She's read 6 more. So we say Abby, take away 6 will get us back to Kristen. So again, that whole thinking there is we have to think about who the person is. And if you're ever stuck in this situation, you're going to want to think, well, how can I make a table to show this, right? In this one, she has 8 more. So I need Kristen plus 8 to get me to Abby. Let's go ahead and prove that that's true. So if Kristen read 9, right? That would mean Abby had read 17. Does that make sense? Is 17 9 more than that? Or 8 more than that? Then yes, that would make sense. That makes sense. On this one, Abby read 20. Okay, so I start with A, take away 6. That means if she had 20, take away 6, well, Kristen must have read 14. So does that match up? Abby read 6 more. Is 20 6 more than 14? Absolutely. All right. So it might be getting a little late in the game here. What I want you to do, kind of like as a last chance, I want you to pause the video one last time. And this time it's just one expression, right? Daryl's been teaching for 1 year longer than Julie. Write an expression for the number of years that Daryl has been teaching. So how much has Daryl have been teaching? So I want you to take this hint and do with it what you will. Let J equal, and now pause, try to finish this row, and we'll call it a day for this lesson. Okay, so hopefully you're back from trying this on your own. So I'm going to say let J equal the number of years Julie, big J there, it's a proper noun, number of years Julie has been teaching. So now if I think about this, if I take Julie, it says Daryl has been teaching 1 year longer than Julie, 1 year longer. So it means whatever Julie plus 1 is, that will give us Daryl. So if Julie's been teaching 28 years, that must mean Daryl has been teaching 29 years. So we have to be careful when we're picking our variables and assigning them for everybody. That will help us to make sure that we get the right people and the right parts of the expression.